Hi everybody, I want to spend a few minutes reviewing factoring trinomials. Remember that we're calling this polynomial a trinomial, tri because there are three terms to it. I like to list these trinomials in order of exponents. So in this case, the x squared term comes first, the x term comes next, and the constant comes third. Now, we're going to factor this thing, but we also notice have the polynomial set equal to 0, and so that's going to play a role in the conversation as well. Anytime that you have a lead coefficient, that's the coefficient of the x squared term in this case of 1, you can start by writing all pairs that give you a product of negative 28, and then you'll look to see if any of those give you a sum in this case of 3. So I might start with, for example, negative 28 and 1, and then I might say positive 28 and negative 1. And I'll move on to, let's see, negative 7 and 4, and positive 7 and negative 4. Now, if any of those pairs give you a sum of 3, then you are in business. If they do not, then you could use the quadratic formula to solve for the zeros. Remember the quadratic formula, and I'll review that shortly. The quadratic formula is used to solve for the zeros of a quadratic. And so in this case, I have 7 and negative 4 that adds to 3, and so I can just factor and say this is the same as saying the quantity x plus 7 times the quantity x minus 4 is equal to 0. Now, each of these quantities, think of this as a times b equals 0. The only way that this can be true is if either a equals 0 or b equals 0. So I can say either the factor x plus 7, we call that a factor, is equal to 0, or the factor x minus 4 is equal to 0. If I subtract 7, I get one solution, x is equal to negative 7, and if I add 4, I get the other, x is equal to positive 4. Now I would encourage you to check your answers. So try putting, for example, 4 back in, and let's see what happens. 4 squared is 16. 16 plus 3 times 4, that's 16 plus 12, is 28, and 28 take away 28 does in fact equate to 0. Same thing's going to happen if you put negative 7 in. So again, we call these your solutions, and if you were to, I won't do this for every one, but if you were to plot this curve, we know that at x equals negative 7, I would have an intersection on the x-axis, and also at x equals 4, I'd have the same thing. We call those zeros because the output or the y value is equal to 0 there. Now because this is positive 1, we know that it's going to be an upward facing quadratic, and so just a sketch, this thing's going to look something like this. If you're curious about your y-intercept, of course you can always just put 0 in wherever you see an x, and you'll notice that the y-intercept is negative 28. All right, moving on to the next one. Again, because I have a lead coefficient of 1, I can follow these rules. I can try to write my pairs, pick out any pairs that give me a product of negative 18, check to see if any of those give me a sum of negative 7. If they do, then I'm in good shape. If they don't, then I can use the quadratic formula to find zeros. And so if I'm listing these pairs, I might say negative 18 and 1, positive 18 and negative 1, negative 9 and 2, positive 9 and negative 2, negative 6 and 3, positive 6 and negative 3. Now, do any of those pairs give me a sum of negative 7? Yes, negative 9 and positive 2. And so if I factor this, I get the quantity x minus 9 times the quantity x plus 2 equals 0. What are my zeros? Well, either this factor has to be 0 or that does. And so x equals 9 is one of my zeros. Again, we call that a solution. X equals negative 2 is my other 0. We call that a solution as well. Third example. Notice again the lead coefficient is 1. I'll do 2 more with the lead coefficient of 1, and then we'll look at some others. And so I need to write out my pairs. In this case, you can, as you do more of these, you'll start to get a little better at coming up with the pairs that work a little more quickly, efficiently. In this case, 7 and 7 multiplies to 49 and adds to 14. And so I end up with, if I'm going to factor this, the quantity x plus 7 times the quantity x plus 7 equals 0. Now, I have this multiplied by itself, and so that's the same as saying the quantity x plus 7 squared is equal to 0. So we only have one solution here. That's going to be x equals negative 7. Next example. Lead coefficient of 1. I need a product of negative 55 and a sum of positive 6. I'm going to suggest that you pause it and try it on your own. Okay. I hope that you found positive 11 and negative 5. 11 minus 5 gives me 6, and 11 times negative 5 gives me negative 55. In its factored form, the quantity x plus 11 times the quantity x minus 5 is equal to 0. My solutions are x equals negative 11 and x equals 5. Again, we call those the solutions. If I was, I'll plot another one for you since I haven't plotted the last few. If I was going to plot this, just a sketch, positive lead coefficients, so we're going to be facing upwards. I've got zeros at negative 11 and positive 5. And if I was going to sketch that curve, it would look something like this. Of course, if you put 0 in for x, you end up with a y-intercept of negative 55. If this was the equation y equals x squared plus 6x minus 55, and we wanted to know what the y-intercept was, we would put 0 in for x, and we would get negative 55. Now, ultimately, we put 0 in for y, which is why we're solving for what we call the zeros. All right, next example. I've got, notice now I've got a cubic, but then I've got an x squared and an x to the first. And so the first question, as we talked about in class, the first question you always want to ask yourself is there a greatest common factor? If there is in this case, if I factor out an x, I've got the quantity x squared minus 2x minus 3 is equal to 0. This is factorable. That's going to be the quantity x, that's going to be x times the quantity x minus 3 times the quantity x plus 1 equals 0. You can double check by foiling. Okay, first outside, inside, last. And then my zeros are going to be x equals 0. My solutions, another way to think of it, x equals 3 and x equals negative 1. Those are my solutions. There are 3 solutions here. Now, if you look at the next example, we no longer have a lead coefficient of 1. Now we have a lead coefficient of 2. And so the only way that we're going to be able to get 2x squared is if I have 2x times 1x. That gives me my 2x squared. In the past, we've always written the products, the pairs that give us a product of negative 9 and give us a sum of 3. That's not going to be the case anymore because we don't have, and the reason is because we don't have a lead coefficient of 1. We have a lead coefficient of 2. So what I still do need to do, though, this 2x times x is going to give me my 2x squared. It'll take care of that need. I still do need to list my pairs that give me a product of negative 9. So negative 9 and 1, draw a line there. 9 and negative 1, draw another line. Negative 3 and 3. And we now have to, basically, we're going to have to guess and check. Okay? Now, I will say down here in the lower left-hand corner, you could use the quadratic formula if you wanted to, no problem. If you're comfortable with that, and I'll show you an example in a moment, use it. But for now, I'm going to guess and check. So when I say guess and check, I mean I'm going to start by putting a negative 9 here and a 1 here. And I do not need to check the negative 9 times 1 because I already predetermined that I'm going to use two values that give me negative 9. And again, I don't need to check the 2x times x because I predetermined using two values that would give me the 2x squared. So that term and that term are taken care of. I just need to know the outside plus inside if it adds to 3. If it does, I'm done. If it doesn't, I need to keep working. So the outside, that's 2x, minus 9x, that does not give me the values that I'm looking for. And so what I would do at this point is switch them and check again. So make this a make this this was going to be a +1 and a -9. Now I'll check again, outside, inside. That's negative 18x plus 1x gives me 17x. And so -9 and 1 does not work either way. You could try 9 and -1, but I think that your intuition probably is telling you that's not going to work as well. And again, you may have to check 3 or 4 combinations before you figure out the one that works. The more you do this, like anything, the better you'll get at it. So I'm going to try -3 and +3. Now I'm going to plan ahead a little bit here. I know my 2x squared and my -9 are good. I need this to be a +3x. And so because this is twice as big as this, I'm going to make my plus over here and my minus here. Because now 2x times +3 is +6, -3 times x is -3, and that gives me my +3x I'm looking for. So this is its factored form. Now, we want to know where it equals 0, so the last thing we need to do is set each factor equal to 0. I'll add 3 and divide by 2. X equals 3/2 is one of our solutions, and I'll subtract 3. X equals -3 is another one of our solutions. Those are called our zeros. Okay. Next examples. And I'm going to, again, say, notice your lead coefficient is not 1. So I need a 3x, and I need an x. That gives me my 3x squared. I need a, well, this works kind of well. The only options to get a 3x, or a 3x squared, yeah, or a 3x and an x. So I'm going to put 3, 1. And for 2, it's just 2 and 1. So the less options, the better, really, if you're in guess and check mode. So again, I'm good on my 3x squared. That's definitely taken care of. I'm about to be good on my +2. I need the combination, the outside, so I need the outside-inside combo to add to 5x. Okay? 2 and 1. I have to use 2 and 1. So the question is, do I put 2 here, or do I put 2 here? You might want to pause it and think about it for a moment. And the answer is I'm going to put my +2 here and my +1 here. Now I've got +2x, +3x, that's my +5x. So what makes this equal to 0? Well, 3x plus 2 equals 0. X plus 1 equals 0. X equals -1. Subtract 2, divide by 3. X equals -2/3. And those are our solutions. Okay. I'm going to challenge you. I'm going to encourage you to try this one in the same way that we've done the others. See what happens. But for this example, I'm going to demonstrate using the quadratic formula. You've probably used the quadratic formula in a prior course, but here it is. -b plus or minus the square root of b squared minus 4ac all over twice a, where b is this value and a is this value, and last but not least, c is this value. All right. So, and again, we use the quadratic formula to find zeros, to find the zeros. So when a quadratic is set equal to 0. So our solutions, our zeros, are -11, so that's 11, plus or minus the square root of b squared, so that's 121, 11 squared, minus 4 times 5a times 2 all over 2 times 5. So -b plus or minus the square root of b squared minus 4ac all over 2a. That equates to 11 plus or minus the square root of plus or minus the square root of 71 all over 10. So I just realized I said 71 instead of 81. Silly me. That should have been an 81, not a 71. The square root of 81 is 9. And so really we've got 11 plus or minus 9 over 10. So 11 plus 9 over 10 is 20 over 10, which is 2. That's one of our solutions. And 11 minus 9 over 10 is 2 over 10, which is 1 over 5. So that's another of our solutions. So if I was going to write this, let's see, in its factored form, I would say x minus 2 is one of its factors, okay? And the other would be 5x minus 1. And the way I get that is whatever is in my numerator goes here, and whatever's in my denominator goes here. So you may want to pause it and think about that for just a moment. But the quantity x minus 2 times the quantity 5x minus 1 would be our factored form there. I'm going to do one more using the quadratic formula just as a review, one more without, and we'll call it. So I'll use the quadratic formula here. Again, if I want and we use that to find where a quadratic is set equal to 0. So if I want to know the zeros of a quadratic, again, I would say my zeros are negative b plus or minus the square root of b squared, so that's 9, minus 4 times a times c all over 2 times a. Cleaning that up, my zeros are going to be negative 3 plus or minus the square root of, well, 4 times 15 gives us 60, or in this case negative 60, and negative 60 times negative 4 gives us what? Positive 240. Positive 240 plus 9 is positive 249. And so I've got negative 3 plus or minus the square root of 249 over 8. Now the square root of 249 I don't believe can be reduced very cleanly or at all. And so we're just going to say that these are our two solutions. The first one would be negative 3 plus the square root of 249 over 8. And the second would be negative 3 minus the square root of 249 over 8. Okay, finally, let's try this other one. And we'll see if it's factorable first. And if it's not, then we'll just say we can use the quadratic formula. So I don't like the way this is written. So I'm going to move everything over to the other side. And by doing that, I'll have a positive lead coefficient. If I do that, I get 0 is equal to positive 3x squared minus 2x minus 8. And so I do not have a lead coefficient of 1. I'll call this a 3x. I'll call this an x. Okay, that's going to take care of my 3x squared. Now we need to think about how we can get our minus 8. So we've got a couple of options, negative 8, or a few options, negative 8 and 1, 8 and negative 1, okay, negative 4 and 2, and then 4 and negative 2. Lots of work to do. Let's just I like to play around with it in my head a little bit. So I need a sum of negative 2. I need that negative 2x. Again, the negative 8 will be taken care of, and so will the 3x squared because of the way we've designed this setup. How can I get a negative 2? Well, if I put a positive 4 here and a negative 2 here, in other words, I'm going to use this pair, that gives me my outside-inside combo of negative 2x. And so this is in its factored form. And again, we set each factor to 0. I'll subtract 4 and divide by 3, so x is either equal to negative 4/3 or x is equal to 2. We call those our solutions. You put those back into your formula, your original formula, you're going to get a true statement. That's all I have.